Welcome to Wednesday, November 26th, 2025 severe weather analysis for Brisbane. This is your 10 a.m. local time sounding analysis. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Looking at this morning's sounding, we are seeing a very stable atmosphere. The basic Skew-T diagram shows the red temperature line and green dewpoint line staying close together near the surface, indicating good moisture with a surface temperature of 27 degrees and dew point of 22 degrees. However, there's a notable inversion layer near the surface, shown by the temperature actually increasing with height. The mixed layer parcel, shown by the blue dashed line, struggles to rise through this stable layer. We have only 101 joules per kilogram of mixed layer CAPE, which is very minimal energy. The blue shaded area showing CIN, or convective inhibition, is substantial at 329 joules per kilogram. This is the lid holding everything down. Storm mode is listed as sub-convective, meaning surface parcels alone cannot initiate without a strong trigger. Now let's look at the afternoon transformation. The enhanced Skew-T diagram shows multiple parcel analyses with both pink and blue shaded areas. Notice the small blue shaded area near the surface representing CIN has essentially disappeared with afternoon heating. The pink shaded area showing CAPE has expanded significantly. With forecast maximum temperature reaching 32 degrees, the mixed layer CAPE increases dramatically to 580 joules per kilogram. The heated mixed layer parcel, shown in orange, now rises much more freely through the atmosphere. The environmental temperature and dew point profiles remain unchanged from the morning sounding, but the heated parcel starts from a warmer surface temperature. The level of free convection drops to around 650 hectopascals, and the equilibrium level extends to around 250 hectopascals. Wind shear remains moderate at 14.5 meters per second through 0 to 6 kilometers. If storms develop this afternoon, the supercell composite parameter of 0.25 and significant tornado parameter of 0.11 suggest scattered storms are possible, but severe weather remains low probability. The hodograph reveals the wind profile through the lowest 12 kilometers of the atmosphere. Winds start from the east-northeast near the surface, shown in dark blue, then veer through easterly and southeasterly directions with height, transitioning to green and yellow colors in the mid-levels. The wind profile shows moderate backing and veering, creating 160 square meters per second squared of 0 to 1 kilometer storm relative helicity. The bunker's right mover storm motion vector, shown by the red star, points toward the south-southwest, indicating if supercells were to develop, they would track toward the south-southwest. The left mover vector points slightly north of east. The 0 to 6 kilometer shear vector of 14.5 meters per second provides enough turning for organized multicells if initiation occurs, but the relatively weak low-level shear limits supercell potential. The atmospheric refractivity profile, or Brunt-Väisälä frequency profile, shows atmospheric stability through different layers. The blue line represents the n-squared values, measuring how strongly the atmosphere resists vertical motion. Notice the elevated duct layer highlighted in orange near the surface, between about 500 and 1,000 meters. This corresponds to the inversion we saw on the Skew-T diagram. Higher n values indicate stronger stability. We see generally moderate stability through the mid-levels, with values around 200 to 250 n units between 2 and 6 kilometers altitude. The profile smooths out above 8 kilometers, indicating more uniform stability in the upper troposphere. This stable boundary layer acts as a barrier to convective initiation, requiring strong forcing mechanisms or significant daytime heating to overcome. This analysis is provided by Distant Curve Remote Area Telecommunications. Always consult the Bureau of Meteorology for official warnings and forecasts. This sounding-based analysis shows potential ingredients but does not predict whether, where, or when storms will actually develop. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.